Sukhoi-27 flanker fighter jet was seen approaching land at 2:40 p.m. local time. At only about 500 feet above the hills, the pilot struggled to navigate the turbulence while glancing at a navigation tablet mounted on the dashboard. The tablet's screen displayed the target coordinates: 2 concrete runways in a village believed to house enemy military facilities. Under each wing, a modified ammunition rack containing GBU's 39 small-diameter bombs was installed. Because the American weapon system wasn't designed for the Soviet mount, Ukrainian engineers had to create a homemade adapter. Low-altitude air vibrations put extra strain on the connection. Each air pocket transmitted vibrations that shook the entire improvised assembly. The parasitic drag from the bombs caused fuel consumption to skyrocket. The AL-31F engines burned about 15% more than originally calculated. The pilot quickly recalculated. He had only enough fuel to reach the target, release the weapons, and return with a narrow margin. The navigation tablet was also flickering between GPS signals and other satellite systems, creating a shift of tens of meters in the target's coordinates. Flying at 500 feet and 450 knots, he didn't have much time to correct the error. Corrections could only be made during the climb. Under the fuselage, an electronic jamming pod is in full swing, emitting noise across the radar frequency band. This old technology can only delay detection by a few seconds for modern radar, but every second gained means getting closer to the release point. About 120 kilometers to the northeast, enemy radars scanned the horizon. 3-dimensional search systems with a range of hundreds of kilometers occasionally picked up the aircraft's reflection as it passed over a hilltop, but its low flight made it difficult to track. In the headset, the radar warning receiver occasionally beeped, signaling a scan that couldn't be distinguished as a normal detection or active targeting. The real threat is long-range fire control radar, which can direct missiles to an aircraft in seconds. The pilot's only protection is to stay as low as possible, even if that means penetrating thick, turbulent air near the ground. 7 kilometers before the release point, he rechecked the checklist. The main weapon switch was active. The indicator showed 3 green lights and 1 yellow light flashing at the last station, a known issue with locally manufactured adapters. The release parameters needed to be rechecked, but turbulence made the instrument readings sound like they were writing during an earthquake. Meanwhile, at the target facility, officers on duty monitored the radar screens. The seemingly lost contact was dismissed as interference or civilian border traffic. The area's point defense system was down for maintenance, unaware of the imminent threat. In the cockpit, the SPO-15 radar's previously intermittent warning signal now emitted a continuous beep. Threat at 195 degrees azimuth. The SA-21 Growler's radar acquisition system, mounted on the hill, had picked it up. There was no hiding place. The pilot applied full throttle and pulled the controls. The 42-second countdown felt like a final verdict. The G-meter jumped to 4.5 as the Su-27 rocketed skyward at a steep, approximately 60-degree angle. The horizon disappeared. An empty blue sky replaced the view of the ground. The aircraft traded low-flying safety for radar vulnerability. External bombs required altitude for range. The target altitude was calculated at about 28,000 feet. Warning lights in the cockpit flashed. The aircraft's wiring and systems protested the aggressive maneuver under the heavy load. G-forces hit. The pilot struggled to withstand the pressure. Left hand on the throttle, right on the stick. Muscular instincts took over. The SPO-15 issued its highest warning. The threat behind ignited the missile launcher. The surface-to-air missile ascended. However, there is a kinematic zone at the top of the climb that must be considered. At 25,000 feet, the left engine surged due to the thin air. The pilot quickly adjusted power. Power returned, but precious altitude was sacrificed. The HUD numbers climbed 26,000, 26,500. Ice crystals clung to the canopy as the aircraft reached 27,000 feet. The pilot's vision was partially blurred. The pilot needed visual confirmation. He looked at the wing alignment indicator. Almost there. The weapons panel showed 3 greens and 1 yellow for Station 4. The release circuit was faulty. The field adapter was temperamental. Time was short for repairs. The pilot decided to release the payload and rely on the bomb's internal logic after separation. At 28,000 feet, he stabilized the aircraft for 3 seconds to allow the weapons computer to calculate release parameters. The navigation tablet now stabilized, showing a green triangle superimposed on the target on the screen. The SA-21 missile behind continued to climb. The seeker began searching, automatic countermeasures through deception. Chaff deception is effective only if the aircraft is maneuvering. The pilot drops the bombs in sequence. Half a second later, bombs 3 and 4 were released from the starboard side of the aircraft. The yellow light on bomb 4 turned green as the breakaway was complete. The 4 GBU-39s were now launching. Their diamond wings unfolded as they began a long trajectory toward 2 buildings containing soldiers. As the last bomb disappeared, the pilot pushed the stick forward for a brutal negative maneuver. The altimeter spun rapidly. Behind, the SA-21 missile reached its peak. Its seeker head searched for a descending target. As the missile banked in pursuit, the Su-27 dived to 15,000 feet and ultimately detonated itself in an empty field. The 4 smart bombs began their final phase, each carrying approximately 36 pounds of explosives, forming a 15-to-1 launch ratio attack formation. They had to navigate the electronic warfare field. 30 kilometers from the target, the R-330's ATEL deployed its spiral antenna. The device flooded the L1 and L2 bands. The bombs switched to the more encrypted but less accurate L5. GPS accuracy dwindled from a few feet to a few meters. While targeting buildings was still adequate, targeting rooms became questionable. Bomb number 2 lost GPS at 90 seconds. The backup INS took over, but its accuracy declined. The bomb's computer ran a Coleman filter, rejecting the obviously corrupted GPS data. Without updates, the bomb flew half-blind. A Ka-52 attack helicopter appeared on the track. The patrol pilot was unaware of the approaching threat. The bomb's radar altimeter detected the helicopter as a threat. The computer calculated and ordered a 5-degree correction. The formation split and flowed on either side of the helicopter, passing within approximately 200 meters of each side. The helicopter continued its patrol, unaware it had been crossed by the smart bomb. At 8,000 feet, a 35-knot westerly wind tried to push the bombs eastward, threatening the apartment block. Each bomb's tail had 4 actuators that corrected the deflection. They worked to a maximum of 15 degrees. If the wind increased further, the bombs would not be able to maintain their course. Deviation to a side target became a real possibility. Revised narrative bomb number 3 was struggling the most. Its tail control actuator vibrating near its mechanical limit. About 8 kilometers from the target, an M2U field radar picked up a small trail on the screen. The operator stared at the dots. 4 small, high-speed objects. The radar cross-section data initially matched a flock of migrating geese, but their speed was 400 miles per hour and their formation was too perfect. The operator marked the contact and reported it to his superiors. By the time the report went up the chain of command, time was running out. The electronic warfare was intensifying. The Zytel jamming system increased its transmit power. trying to drown out the bomb's GPS signals. But each GBU-39 used a narrow pattern antenna that reduced the jamming effect. It was like a digital chess duel at the speed of light. Bomb number 2 suddenly regained its GPS signal. The 30-meter position error began to shrink thanks to its internal filtering algorithm. 2 minutes before impact, all 4 bombs had descended to 5,000 feet, locking onto their targets. They were too small and silent to be seen or heard from the ground. In the eastern barracks, soldiers played cards and talked about football. In the western barracks, dinner was served. Someone complained the beer was cold again. At the Petrivka command post, the duty officer finally processed the radar report. 4 aerial objects resembling precision-guided munitions were approaching within 5 kilometers. Sirens blared, but the laws of physics could not be stopped. Moving objects kept moving. The S-1 defense crew chief dropped his coffee and ran to the weapons station. The defense system had just been brought up from standby. It had taken 45 seconds to prepare, and he had less than 30. The 1 R-21 radar began swiveling, searching for targets it should have tracked 5 minutes ago. The 30-millimeter autocannon revved up, hydraulics screaming as the barrel aimed skyward. The fire control computer tried to track 4 objects smaller than soccer balls, traveling at 380 miles per hour, already within the missile's minimum range. The surface-to-air missiles and their tubes were useless, requiring a 1 to 2 kilometer activation range. The bombs were coming too fast. Chaos erupted. Soldiers scattered from buildings, some diving into drainage ditches, others frozen in confusion. The defense radar finally spotted the target, but the 4 bombs were so close together that the system only locked onto the center of the formation. Both automatic cannons fired, firing 30-millimeter tungsten projectiles at 5,000 rounds per minute. The sky was full of metal, but the bombs had a smaller radar cross-section than the system was designed for. The shells passed 30 meters behind the bombs. At 500 feet, the 3rd bomb finally stabilized after breaking through the wind shear. The control surfaces bit into the air, pulling it back onto its course. The 4 bombs passed through the curtain of fire. The cannons spun frantically, trying to lock onto targets they had already missed. The terminal phase began. At 2:51:03 p.m., the first bomb pierced the roof of the East Barracks like a 250-pound steel needle. The steel nose cone pierced 2 floors of concrete before its programmed time fuse triggered. Deep inside the building, 36 pounds of AFX-757 exploded, creating a pressure wave of thousands of psi. The facade of the East building was blown out, windows shattered, walls turned into projectiles. 17 seconds later, a second bomb struck the western side of the same building, just 6 feet from the programmed coordinates. The structure collapsed like a hotel hit by explosives. The West Barracks received the 3rd and 4th bombs almost simultaneously. The first bomb pierced the main door and the central stairwell, where soldiers were running for the exits. The 4th bomb pierced the roof of the central section. Within 1 second, 72 pounds of explosives detonated in the same building. The pressure waves converged and multiplied. The structure didn't just collapse, it shattered. The walls flew outward like a flower of destruction. Within 30 seconds, 2 reinforced concrete barracks were gone. Every base within range now knew the risks. Move or perish.